So we've got a brand new marking period, brand new chapter, brand new subject. We probably have not done this before. I don't think we did this in Algebra 2. We may have, I can't remember. I don't think we did, but we might have. It's called symmetry and coordinate graphs. We've done coordinate graphs. You know all about that, X and Y, right? Ordered pairs, and you draw lines and all that kind of stuff. We're going to get to that in a little bit. But first of all, I want to talk about something that's called symmetry. If you talk about something that is in symmetry or symmetric with something, it means it's basically, this is not a formal definition, but as far as we're concerned, it's basically like a mirror image, right? If you look in the mirror, it's symmetric. It looks just like you, right? Raise one hand, it raises one hand, okay, or whatever. So that's just an easy example of symmetry. So, for example, let's see. Yeah, I guess I will grab a graph to start with. Now I'm going to teach this a little different than what I've had in my notes. So I may stumble once or twice because this is the first time I've kind of taught it like this particular way. I really don't care for the way that the book does a few things. And last year when I took the notes on this for the first time, I did it as the book, but then I thought about it. There's a lot better way to talk about symmetry. And I didn't really put a lot of notes together for that, but so just bear with me, that's all I'm saying. All right, let's put a graph here, and we'll put a line. And let's just put any old line. I don't really even care what it goes through or anything like that. All right, so let's say, let's make it go through the origin, just make it easy. All right, so we got a line right there. So if I talk about something that's symmetric, let's put the origin right there, because we're going to talk about being symmetric with the origin in a minute. If I did this, well, let's just talk about something being symmetric. If I had, let's say, a ray right there, and I said, what is symmetric with this? Basically, if I just took this and just flipped it like 180 degrees, that would be considered symmetric. So if I took this and flipped it so it's going this way, it would look like that. Do you agree? So you kind of have two rays, one going this way, one going this way. They would be symmetric to each other. If I took it and I folded it onto itself, that's an example of something that is symmetric. Let's do another graph. Now, this graph right here is something, I don't know in this class if we'll do this or not, but there is a graph that looks like what I'm going to draw. Don't worry about how to graph it. I'm just going to show it to you and show you what symmetry kind of is. So let's take one, I don't know, let's say it starts here and it goes, I don't know, 1, 2, 3, 4. Again, it doesn't have to be perfect, but let's say this thing curves like this, curves like that, but then, watch this. If I wanted to flip this on the other side of the y-axis, what would this look like? So instead of going to 2, 0, where do you think this point would be over here? It'd be at negative 2, 0. Instead of this being at, what is that, 8, 8, 4, what would it be? Negative 8, 4. Everybody see that? And then instead of this being 8, negative 4, this would be what? Negative 8, negative 4. Do you see the symmetry? It's kind of hard to draw. There, that's not too bad. There we go. All right. So they're symmetric to each other. They look the same. They're not exactly the same, are they? But they look very similar to each other, except one is flipped on the other side. There's a lot of different ways they could be symmetric. This is considered symmetric about the y-axis. So if I took this, let's say I had a sheet of paper and I had one graph on one side, one on the other, and I folded, well, let's do this. Yeah, let's say, and then I folded it, right? It was a piece of paper, and I folded it right down that y-axis, then those graphs would match up exactly, wouldn't they? You see that? I'm not going to do that for you, but you can imagine that happening. So that's basically, those two examples are basically what's considered symmetric. Let's talk about this. There we go. Okay, one more dot to get rid of. There you go. All right, so now what we're going to do is we're going to talk about four ways that we can be symmetric. All right, one way we could be symmetric. Nope, come on, pen, help me out. There's a couple ways you could say this. A lot of times you might hear somebody say it's symmetric about the y-axis or the x-axis or something like that. Or a lot of times you'll see with respect to. If I say it's symmetric with respect to something or it's symmetric about something, it really means the same exact thing, all right? I could use those interchangeably. I think the book uses symmetric with respect to, all right? And so what I'm going to have four different things. This is supposed to be a colon. Respect to, all right? The first one we're going to talk about is respect to the origin. Actually, we may go in a different order when I write these out. And then we're going to have, it's going to be symmetric with respect to the x-axis. There might actually be 5 of these. I mean, you could have a multitude of these, really, but these are 4 we're really going to talk about. And then we're going to have it with respect to the x-axis. I'm sorry, y-axis. I was looking at that. I wrote y. The y-axis. And respect to the line. I'll even write this, the line, just so you know this is a line, y equals x. There's another one with respect to the line y equals negative x, but we're just going to stick with these. These are your like main 4 things that you're going to do. First of all, what in the world does that mean? Respect to the, let's do the x-axis first. So for instance, if I had a point, I don't know, let's go 4, 3. Everybody see that? That point is 4, 3. So we're going to talk about lines in a minute, all right, but let's just talk about the points first. This is what I did not have in my notes, but I was actually watching a couple videos and a couple on YouTube, and a couple teachers did the thing with the point. I was like, why doesn't my book do that? It makes it so much easier. So that's what we're going to do. So let's say you start off with this point 4, 3. What is the point that is symmetric with respect? Let's start with this one first, all right, with the x-axis. What does that mean? If I folded that graph on the x-axis, where would this point be located? So I took it like this, right? So here's my graph, and I folded it along the x-axis. Where would that point be if I folded it? It'd be 4, negative 3. Very good. So 1, 2, 3, 4, and 1, 2, 3. Everybody see that? Do you understand what I'm doing? So I'm using this x-axis with respect to the x-axis. This is the one that I'm doing right now. We'll get to the origin in a minute, all right? Let's do the x and y first, then we'll do the origin. All right, so with respect to the x-axis, you would switch. Look what you do. If it's with respect to the x-axis, the x stays the same. What changed? The y. It changed from a positive to a negative. I could have started with 4, negative 3, and I say, what is the point that is symmetric with respect to the x-axis? You would keep the x the same, right, and then change the y value, or change the sign of the y. Does that make sense? Yes, right, that's the sign, positive, negative, all right? But you can think visually about folding it. Fold it along the y or the x-axis. If I fold this along the x-axis, it flips over the x-axis. Do you see that? It flips basically 180 degrees, right? Do you see that 180 across that x-axis? So that's with respect to the what? To the x-axis. Or I could say it's symmetric about the x-axis. I could use those phrases interchangeably. Everybody with me on that? All right, this is different. I don't think we did this in Algebra 2 last year, did we? I didn't think so. All right, so that's that one. Now, what if I start with this first one in the first quadrant, and I wanted to find a point that's symmetric with this point with respect or about the y-axis. So now this time, how am I folding it? I'm folding it along the y-axis. So where's this point going to be if it's symmetric with the y-axis? Or I could say symmetric with, all right? With, about, with respect to. It's all interchangeable. It just depends on what teacher says what. Yeah, negative 4, 3. Very good. 1, 2, 3, 4. Then 1, 2, 3 right there. So that would be negative 4, positive 3. Now again, look what we did. When it was with respect to the y-axis, we kept the y's the same, didn't we? All right, and we changed the value or changed the sign of the x. All right, so with respect to the x-axis, you keep the x's the same, you change the y's. When it's with respect to the y-axis, you keep the y's the same and you change the x's. Is that something you can remember? All right, and you can visually, I watched a video last night where the guy actually had a piece of paper and he did it with a Sharpie so you could see through the back of the page, and he actually took it and folded it and you could see where it was located and that kind of thing. But I don't think we need to do that. I think you can visually do that, can you? All right, so if this was my fold, this would flop over to here, wouldn't it? All right, so this point would be symmetric to this point with respect or about the y-axis. What do you think? So we've done this one and we've done this one. Let's go to the first one, the origin. What do you think we're going to do when it's with respect to the origin? So we did the x and the y. So what we're going to do with respect to here, what we're going to do is we're going to change both of the signs. All right? So the origin, it's kind of like a combination of these two. That's why I did these two first. All right? So what do? We change the x and we change the y. So where would that point be? Negative 4, negative 3. It would be right there. Negative 4, negative 3. This one is with respect to the origin. Okay, it's symmetric with respect to the origin, or symmetric about the origin, or symmetric with the origin. Again, people use different phrases for all of that. We good with that? All right. Let me just check something real quick here. Let's forget the y equals x right now. Let's just stick with these three. Okay? It'll make more sense when we actually do a line with the y equals x. So does that make sense? So if I give you a point and I ask you, because a line is just a whole bunch of points anyway, isn't it? All right? So that's what we're talking about right now with the points. If it's symmetric with respect to the x-axis, you keep the x the same, you change the sign of the y. If it's with respect to the y-axis, you keep the y's the same and you change the sign of the x's. If it's with respect to the origin, you change both of the signs. All right? Now you could have started with this one and I could say what point is symmetric to this with respect to the x-axis, then you would go to this, right? You don't always have to start with the two that are positive. I just did because it makes it a little bit easier. Does that make any sense at all? No. All right. Doesn't? Let's write them down. If it's, well, you just change both of them. Let's do this. Let's write it down like this. If you have a point xy, okay, and I wanted you to find a point, what? We'll get to that in a second. We're getting to that. We haven't touched that yet. All right, let's just do the points right now because that's going to lead us into actual lines and curves and all this kind of stuff, all right? So if you said it's symmetric, we'll just say with, okay, the x-axis, then what would your point be? Remember, if it's symmetric with the x-axis, we keep the x the same, don't we? So this would be x, and you change the sign of the y. So what would the y be? It'd be negative y, which means just the opposite sign of the y. Does that make sense? If it's symmetric with the y-axis, then what would your point be? You keep the y the same, right? And you change the value, or you change the sign of the x. So that would be what? Negative x. Make sense? If it said it's symmetric with the origin, you change them both. Okay? Make sense? Okay. So, with the fire drill, we don't have enough time to really get to the lines just yet, but we will tomorrow. So I'll give you a little sneak preview of what we're going to do tomorrow. Tomorrow, let's grab this graph. I split this up into 2 days anyway, so I knew it would take 2 days to do this. So we won't be behind. Not that you care, but. So tomorrow we're going to have, we have all kinds of graphs. We're going to have a graph. I'll just start it off for you, and we'll continue this tomorrow. A graph like this, y equals x cubed. You graphed those last year, didn't you? Yeah, we graphed parabolas, didn't we? Yeah. Right? They look like this. That would be an x squared graph. And I'm almost positive we did the x cubed. You may not remember, but that's okay. If you don't remember, you could always do this. Put an x and put a y. Put a couple values in for x. Negative, let's say 2, negative 1, 0, 1, 2. I could put more in there, but if I put more in there, it's going to go way off my graph anyway. Do you agree? Yeah. So let's put some numbers in here. Negative 2. What if I put a negative 2 in for x? What am I going to get? No? Negative 8. Negative 8, because it's odd, right? It's an odd exponent, and when I have a negative, I'm always going to get a negative when it's an odd exponent. Agreed? Right? Because negative times negative is positive, times another negative is negative. Right? So anytime you have a negative, or sorry, an odd number of negatives, your answer is always going to be negative. If you have an even number, if this was to the second, to the fourth, to the sixth, then you always get a positive answer. Everybody with me? Okay. Put a negative 1 in for that. What are you going to get? Negative 1. Put a 0, 0. Put a 1, positive 1. Put a 2 in there, positive 8. So what's this graph start looking like? Negative 2, negative 8. I think this goes down to 8 right there. And then negative 1, 1 would be right there. 0, 0 would be right there. Yeah. Is this a straight line? No. It's not really a parabola, but it does curve. And it goes like that. But is that all there is to it? No, you got the positives as well, right? 1, 1 would be right there. 2, 8 would be there. What if I put a 3 in there? How far up would I go? 27. That's why I didn't put that in there, because I don't have near enough room there. So this, whoops. It doesn't go completely straight. It kind of looks like it does when I graphed it. But it does. Is the further up or further to the right you go, the further up it goes. Everybody see that? So what we're going to do is we're going to figure out, we're going to draw this with respect to the x-axis, with respect to the y-axis, and with respect to the origin. Does that make sense? Yes. All right. It's just like a whole bunch of points, right? So we learn how to do 1 point. Now we're going to learn how to do a bunch of points. So that's tomorrow. We'll continue that tomorrow. No homework tonight.